Hello, my name is Christina Campos, and I'm from West Oso ISD in Corpus Christi, Texas. And today we are going to be sharing our reset 5E STEM unit on water filtration.
Okay, hi, my name is Melissa Whitehead. I'm from Redwood, Mississippi. I work at Vicksburg Junior High School in Vicksburg, Mississippi, and I am Christina's partner in this activity.
And today we're going to be sharing with you the 5Es. So we'll start by our subject and grade level is going to be science, engineering, and computer science. And the grade level for this particular assignment is middle school. Our materials that we use for this particular project, is clean water. And then we also use clear plastic cups. We prefer to use 6 per group, measuring spoons and cups, plastic spoons, granular activated charcoal pellets and powder, pens or markers, a timer, 1 per group, food coloring, 1 per group, paper towels, gloves, and safety glasses for every student. These are some optional things we've added. You can also use sand, petals, and cheesecloth, cotton, and coffee filters. The 3 standards that we've added into our lesson is the next generation science standard, which is apply scientific principles to design a method for monitoring and minimizing human impact on the environment. We also obtain the combined information about ways individual communities use science ideas to protect the Earth's resources and environment. Computer science standards, we collect data using computational tools and transform the data to make it more useful and reliable. We also added some English language arts standards as well, site-specific textual evidence to support analysis of science and technical texts, integrate quantitative or technical information expressed in words in a text with a version of that information expressed visually. So we're talking about flowcharts, diagrams, models, graphs, or tables. Our lesson objectives, students will be able to understand the importance of clean water. They'll also be able to identify sources of water pollution. And they will also be able to explore ways to conserve and protect clean water sources. Use granular activated carbon to determine the effectiveness of removing food coloring from water samples. And they will also use collected data to create graphs and to aid in data interpretation. And they will also design and test their own filter using the engineering design process.
Okay, our career connections with this project came from Mr. Luke Grotowski. He is a research chemical engineer at the U.S. Army ERDIC's Environmental Engineering Branch in Vicksburg, Mississippi. I was privileged enough to work as an assistant with him this past June. And he is a lead researcher using material science and environmental treatment to support both military and civil work missions. His primary focus, he uses nano materials and novel technologies for a variety of applications. He very specifically has 2 main projects going at this time. One is the reduction of cyanobacteria and cyanotoxins in fresh water, as well as removing munitions and other dangerous chemicals from different types of soil structures.
We also wanted to add some STEM careers into our lesson because we feel that that is super important for our students to make those connections. So here's a few that we've added in for chemical engineering. We've added process engineering, chemical plant manager, environmental engineer, material scientist, pharmaceutical engineer, safety engineer, energy engineer, and then we also added some Master of Science in Civil and Environmental Engineering, environmental consultant, a water resource engineer, a geotechnical engineer, and there's a few more listed. Some of our favorites I just mentioned. The engagement is we're going to open an interactive presentation that we made on CurePod. And here's the presentation that we have created for our students to interact with us. So we're basically going to ask those open-ended questions for our students to answer those. Take a poll, and then we're going to actually work together to kind of create the importance on the quality of water. And then we're also going to indicate some water sources. We want our students to draw out some of their things that they've learned. We want to show them currently what water pollution is, because I feel like if they see that, it would be more relatable. And then we also did, we're doing some more drawings there. So this QPod is actually any teacher is able to use it. It's open to use. You can make a copy of this and you can use it with your students and have them being engaged as well. So we wanted to really our focus was really obviously on clean water in the environment through this project, this visual tool. So we wanted to make sure we're getting that across. And so we do talk about that here in our steps 1 through 3. And the timelines as far as how long we could take with this project, with this visual tool. And so we want to present this to our students and allow them some time to kind of do that. Then we also want to, during step 3, assign our groups for the next class period to pass the cups out and start to get going on that.
Okay, for the exploration portion of the experiment that we will use, the students will use both the pelleted and the powder form of the granular activated charcoal or carbon, commonly called GAC in the scientific community. I learned at ERDIC this summer, and food color to perform a very simple water filtration experiment. So the students have already been divided into groups. They've already labeled their cups. So this will be what I like to call where the rubber meets the road. They're going to measure out 2 cups of water and place in each of their 3 plastic cups to start with. And then they will add 3 teaspoons of GAC to each cup. And this will be the pelleted form to start with. And then the variable in this case will be the amount of food color that is placed in each cup. So after they will start off with a half a teaspoon, mix that well in the first cup, and then they will time to see how long the GAC takes to remove the color from the cup. The second cup, they will add a larger amount, like 1 teaspoon, and then the third cup, they will do 1.5 teaspoons of food color, and they will time each one of those. So as they time each one of these, they will record their data onto a spreadsheet so they can use to make a graph to help explain the results and their data at the end. So then when we get to part 2, we're basically going to repeat steps 1 through 5, except this time we will use the crushed GAC instead of the pelleted form. And then once they have ran their 3 different experiments, they've got their times entered on the spreadsheet, they will make comparisons between the crushed GAC versus the pelleted GAC, and they will make inferences as to why they achieve different times using the crushed and pelleted forms of the GAC.
Very good. So the explanation on that is students will analyze the data and the results, and then we'll allow some time for our students to ask the question about why. Why is it different with the GAC? Give the different times of results and kind of do that. We're also have our students do some research so they can start to prepare their slides and their presentation explaining the results and of course why the results are different based on the types of carbon used. This is a really good time for our students to actually take a visual understanding, like what we're trying to teach them as far as clean water filtrations and things like that. And it will be also an eye-opening moment for our students to see those differences. And then we also want to make sure that our students are explaining their graphs. They're able to explain that data to us and give it to us in a practical manner. And then we'll also, step 3, will allow time for our students to present their slides to the class.
Okay, so for elaborate, this is where our engineering design process comes in. This might be a 1 class period thing for you. This might be 2 or 3 days for you. It just depends on how much time you have to spend on the unit. So we're going to have the students try a real world application to create a simple water filter that will help them create clean water. So the first thing that we'll do, we're going to allow the students just a few minutes, about 10 to 15 minutes, to do some quick internet research to look at designing a home water filter. It doesn't have to be anything really fancy, just to give them some ideas, help them brainstorm some things. We're going to allow them some time to sketch out their simple filter designs on paper, including a hypothesis on how well they think that their filter design will remove the color from the water. So we need to make sure that the students know in advance what materials they have to choose to work with. Okay, so after we do that, we're going to allow the students to gather their materials from the supply area. The students will then assemble their filter prototype. They may use up to 3 different types of the media available. In this particular thing, you might change this a little bit, plus the coffee filters to build the filter. So once the filter is complete, they're going to prepare a mixture with food color and just plain tap water. And they're going to observe how long it takes the water to flow through their filter. And they're also going to give that a color rating, where 0 is the water has come through totally clear, or all the way up to 10, the water is the same color as the original sample. They will test their sample 3 different times to see if there is any difference from the first sample all the way to the 3rd sample. So once they have completed that, they've recorded their data, then you can allow them to go back to make changes, to answer their hypothesis. Yes, my hypothesis worked. No, our hypothesis didn't work. And then if time allows, you can allow them to make changes, to maybe get with other groups to see, hey, this is what we did, this worked, or this is what we did, no, it didn't work. And then allow them to make changes to improve on the design of their filter.
And the whole time we're using we're using the engineering design process, as you can see Melissa stated. So our next one is going to be our evaluation. So students are understanding and will be addressed through their presentations and their filter creations. I love this project. When we talked about it, I love the fact that the students get to create something and they get to actually share that creation with the other students. I love that we have a time in there for students to share. So we will be building a presentation. The students will actually be sharing their research findings to the class. And then we also put in some time for Q&A to have some classroom discussions on the presentation. And we want to make sure we're reinforcing the learning. Number one, about the pollutions in water, and also how they can build their own water filtration for the future.
Okay, and then just for reference, we do have these references at the end that guided us in the creation of this unit.
Thank you very much for your time.